Most computer programs exist to process data. The data may represent a wide variety of real-world information, such as personnel records, inventory, text documents, and the result of scientific experiments, and so forth. Whatever it may represent, data is stored in memory and manipulated in similar ways. You may be familiar with a course called Data Structures and Algorithms. The term data structures refers to the way data is stored in memory, and algorithms refer to how it is manipulated. Standard C++ includes its own built-in container class library, which can be used as a standard approach to storing and processing data. These containers which store data may be organized as stacks and linked lists. The algorithms are procedures that are applied to these containers to process their data. Algorithms are also represented by template functions. Now, iterators are a generalization of the concept of pointers, so they point to elements in a container. Iterators can be incremented, as can a pointer, so it points in turn to each element in a container. In everyday life, we commonly group similar objects into units. We buy peas by the can and eggs by the carton. So in computer languages, we also need to group together data items of the same type. The most basic mechanism that accomplishes this in C++ is the array. Arrays can hold a few data items or tens of thousands. The data items grouped in an array can be simple types such as int or float, or they can be user-defined types such as structures and objects. Arrays are like structures in that they both group a number of items into a larger unit. But while a structure usually groups items of different types, an array groups items of the same type. More importantly, the items in a structure are accessed by name, while those in an array are accessed by an index number. So using an index number to specify an item allows easy access to a large number of items. So now let's look at some code examples of how to declare, store, and access items in an array. To declare an array, we define the variable type, then we specify the name of the array followed by square brackets. Then we specify the number of elements that it should store. So in my example, I am going to declare an array that can hold 4 elements, and we will be storing the names of different types of vehicles. So in this situation, my array type will be a string, and let me call my array vehicle. And then using my square brackets, I will indicate that it is an array and it will be holding 4 values. Now I need to initialize my array with some values. So since my array is of type string, remember I need to wrap the elements of the array in quotations. So the first value, let's say we have a Honda, BMW, let's throw a Mazda in there, and let's throw a Tesla. So that is pretty much how we define an array in C++. First we have the type, the array name, our square brackets indicating that we are defining an array, and then inside we put the number of elements that the array would hold. A different way to initialize an array would be to initialize it with the actual value. So remember, once the value of an array is set, there is no change in it again. So if I wanted to create an array that would store student grades, I could dynamically set the size of this array, and this one won't be a string. Let's set the return type for this to be an int, and then inside this array we can now put our grades. So let's put a couple of grades in there. So 95, 64, 71, and let's put a 83. Alright, so these are the two different ways you can declare an array. You can either set the size initially, or you can just allow the program to determine at compile time how many elements your array is storing here, right? So we have created an array with some strings, and we have also created an array with integers. So remember, each one of these is called an index. So if we wanted to access the value at any one of these indexes, then we would have to pretty much call it using the element number. So we first refer to the index number, and that index number will access the value of that element at that index number. So keep in mind, arrays start at index 0. So if we wanted to print the first element in our vehicle array, we would have to print the element at index number 0. So in order to do this, we would do a cout statement, and let us say vehicle. We would open up our square brackets, and we want to specify the index, which is 0. So just to reiterate, an array begins at index 0, not 1. Okay, so the first element in an array begins at index 0. So by that logic, if I print out the element at index 0, I should get my Honda. Okay, so it prints the Honda. Let me, going forward, let me increase this font a little bit. Let's say 24. Okay. Right, so it prints our Honda for us. All right, so it's the same concept. If you're trying to access any element of the array, if we wanted to change the value at element 0, we could simply say vehicle, specify that we want to set a value at index 0, and we want to change the value to, let's say, what's another car? Let's say we want to put a Pontiac. Sorry. So now if we run our program, we'll see here that now the same index 0 now gives us a value of Pontiac, because we have specified that we want to change our value at index 0 to a Pontiac. So it would be the same idea if we wanted to print out the 5th element in our student grades. What index do you think that we should specify for it to print out? Right, we would start counting at index 0, so 0, 1, 2, 3, and 4. So if we wanted to print out the 5th element, which would give us the number 83, we would have to print index 4. So let us comment this out, and let us print student grades at index 4. So if we try to print index 5, we would obviously get some crazy number, right? So I'm surprised the program even ran, but that is definitely out of the scope of what we are doing right now. So if we want the correct answer, let us change that to 4. And now when we run it, we get our score of 83. So if we wanted to print all the values in our array, we would need to use something we've already looked at. We would use loops. So in this scenario, we would use a for loop if we wanted to print all of our vehicles to the screen. And to be able to do this, you will need a couple of different control elements. So let us define our for loop. And the first thing we need to define is our iterator, which would be iterating over our indexes. So let's set that to 0 because our array starts at index 0. And then let us say, as long as our index is less than the number of elements in our array. So we're using the vehicle array in this case, so we know that that number is 4. We would like to then increment, let's put a little space. So we would then like to increment our iterator. And now inside our block, we would want to say cout vehicle. And since we now have an iterator, which would be I, so this is what will be cycling through our array of 4 elements and then being incremented by 1 each time. In here, in our square brackets, at this point, we would like to use our iterator. So it starts at 0 and ends at 4, right? So we have 0, 1, 2, 3 elements in our car array, so it will stop at 4. So that looks correct. So let me run our program, and this should print all the cars in our array. And of course, everything is all joined as one string. So if we wanted to make this a little bit more readable, we could simply include a space. Okay, so there we have it. And of course, if you wanted each element on a different line, okay, there you have it. So that's how you loop through an array to output the index of each one of the indexes. So let's say I wanted to define a function called print array that I could pass either my vehicle array or my student grade array to, and it would simply print those values for me. So I would need a couple of different parameters. So if I'm going to pass an array to a function, I would definitely need a parameter that takes an array. And secondly, I would need a parameter that takes the number of elements that are in that array. So let us brainstorm this and think about it. So we need an array, or a function called print array, and this function needs to take an array and the number of elements as parameters. Okay. So first, let us define our array. So in this situation, I will use a return type of void, as I am not returning a value, but I am simply printing the items to the screen. Now, the first parameter will need to be an array, or let's use an integer, and also let us use, we cannot use the keyword of array, so let us use ARR to specify that this is an array. And then of course we need what is known as the length of the array. So remember, the length of the array means the number of elements starting at 0 that are inside the array. Now inside this array, I could easily put this for loop here. So let me just cut this for loop out and paste it inside the body of my function. So now a couple of things need to change, right? So since we are passing in the length of the array as an argument, we no longer need a hard-coded literal to define how many elements are in the array. So first thing we would change, of course, is that hard-coded literal, and we're going to set it to the length of the array. Secondly, we need to change this to the value that is passed in. So here we are specifying that that ARR is actually the variable that will be holding our array for us. Okay, so let's see if this needs anything else. All right, the only thing we need to define is the prototype at the top. So that would be void print array. And of course, it takes an int. It takes 2 ints. Okay, we may need to specify that this integer is an array, but let us try running our program first and then correct any errors as we go along. So now I want to call my function print array, and I want to pass in my student grades and the length of my student grade array. So that would be 1, 2, 3, 4, 5. So the length is 5. Okay, so now let us test this. And we have errors. So we may need to actually, since it's an array, we need to specify here. Okay, so that was the problem. So usually you may not necessarily need the variable name, but in this case, since we're passing an array to this function, it would require us to specify that, okay, the first parameter is in fact an array and not just a simple integer. So let us now try running our program. And of course, our function prints all the values in our student grades array. All right, so that's great. So now we have a function that we can reuse, and we can use it to print our vehicle array. But remember one thing. Okay, so yeah, I should be able to simply, even though it's a string, my function returns a void. So I should be able to plug my vehicle array in, and my vehicle array has a length of 4. Okay, all right, so that's what I was expecting to happen. So here we have an error now that we're trying to pass in our vehicle array, which of course is of type string. It's telling us here that in our array definition, the argument type is incompatible with parameter of type int. So this means since in our function declaration, we have an integer as the first parameter, it's saying that it's incompatible with what we're trying to pass in since vehicle is of type string. So what we'll need to do in a case like this is to overload our function. Okay, so overloading our function, so what this means, I am going to take the very same function definition and just change a few things about it. So it's going to have the same return type, the same name. The only difference is I'm going to change the first parameter to be of type string. And I think that should be all that is needed. So we're still passing in a string, we're still passing in the length, and everything should remain the same. So the only thing I need now is to add this function prototype, and I'm just going to copy it and change this to a type string. Okay, so this is known as function overloading. So we have two definitions of print array that have the same name, same return type. The only difference is we are passing in an integer as the first parameter in our first definition, and then in our second definition we are passing in a string as the first parameter. And you can overload functions as many different times as you need to, and it can have different function definitions can have additional parameters. For instance, this could also take a double and a number. So that's all there really is to know about overloading a function. It's the same return type, same function name. However, the parameters that it takes may vary in type or in the number of parameters that are passed in. So now our print array for vehicle should work. So let's run this. And here we get our string array that's printed out. Okay, so there you have it. We have done our array definitions. We have added items to our array, string and integers. We have overwritten a value at an array position or index position, and then we have defined and overloaded a function that will print an array of integers and also print an array of string. All right. Vectors. Vectors can be thought of as smart arrays. They automatically manage storage allocation for you, expanding and contracting the size of the vector as you insert or erase data. You can use vectors much like arrays, accessing the elements with the square bracket operator. A vector size is automatically increased to hold new items using add or push to add data items to the back of the vector. Now let's look at some code examples. So before we can use vectors in our program, we first have to include our vector library. So we do an include vector, and let us define a vector of type int. and let's call it v1. All right, so now we have our vector defined. Now that we have our vector defined, we can use a for loop to fill this vector with some values. So we can say for int, let's define our iterator equals, let's set it to 1 this time. Let's say I is less than 5. And we want to increment by 1. We can use what is called the pushback function to populate our vector. So we can say v1, and when we hit dot, we can see the pushback operator. So remember, we're dealing with objects, and a vector is an object. So we will soon begin classes and objects, and you will further understand how to define your own personal classes. So think of vector. We included the vector library or class, and it allows us to access different we can say methods or functions that have been predefined, and one of those functions is the pushback function. All right, so we're going to do a pushback, and we just need our iterator there. Now that is defined, we can print out our vector. So we can say the size, and then we just do v1 dot size, right? So this will print the size of our vector. We can do another one, and we can print the capacity. So first, let me ensure that I am putting an end line. So of course, for capacity, can you guess which method we would use? Of course, it's right there, capacity. And let us look at another function, and let's call this one max size. And of course, for max size, there is a function called max size. All right, so let us run our program and see what we have thus far. Okay, so here we see that the size of our vector is 4, the capacity is also 4, and of course this is a huge max size. So you can see that vectors can hold quite a bit of data inside of it. All right. So one thing we could do, we could resize our vector. So if we did a v1 dot resize, let's say we wanted to resize it to 3. Now let us copy this size print statement and run it after the resize. Let's say the size after using the resize function. Right, so size after using the resize function, of course, is 3. So let me just drop a new line right here and run it again, just so you can see it more clearly. Right, so the size after using the resize function is 3. So let's take a look at some other built-in functions for vectors. Next, we can look at the insert, assign, push back and also the pop back functions. So for this example, let us actually define, let us comment this out or remove it for now. So we're going to use our vector again. Okay. So let us now assign some values to it in a different way. So let us say v1 dot assign, and we would like to fill the array with 10 5 times, right? So we would write that as, right, so we're filling this vector array with 10 5 times, and in order to see that output, and let me just put a comment here, just so that it's clear. So let's do a print statement. And then we need our for loop. So we can say for int, and we're setting up our iterator. And now we can use the size method. So we can say I less than v dot size. Actually, it's v1 dot size. So we want to increment our iterator. And since this is just a single line, we're just going to do a cout v1, put our iterator in there, and let's ensure we have a space there. All right, so this should print 10 5 times. So let's run this. Right, so the vector elements are all 10, and you can see it printed it 5 different times. So there are a couple more things we can do with our vector. Let us insert 15 to the last position. So in order to do this, we can do a v1 dot push back, and this will push the value, of course, to the back of the list. Okay, so now let's create a variable called n, and n will hold the size of our array. So now we would like to print the last element in the array. So let me first drop a new line, and the last element is, and to get the last element in the array, we actually have to do v, and then we're going to do n, which is the size of the array, minus 1, because theoretically the last element in a vector is different from the last value that we have defined in the vector. So we have to do an n minus 1 to get the last value that we defined, and this should be v1. All right, so everything is matching up. Now let us run our program. Okay, and here we get the last element is 15. So if we want to remove the last element that we just added, so remove last element, there is a method called popback, and this will remove the last element in our vector. So now that we have removed it, let us copy this print statement and paste it here. And we may need a new line put in there somewhere, right? So let us just add a new line here and run this again. So you can see that after the pop back, we have removed our element 15. And if we comment out the pop back, of course, and run our program, this second print statement should of course print the element or the vector with a 15. So let us set that back. All right, so let's take a look at a couple different methods we can use. So we can insert value at the beginning of a vector. And to do this, we use the insert operator. So we want to insert, and this will take a parameter of the beginning. So v1.begin, and then the value we want to insert is 5. All right, so we have that. So let us move this print statement. So remember, this is all sequential. So I'm putting it right here so that we can print this vector and see that the 5 has been added. So here we see that 5 is now at the beginning of the vector. And of course, if we want to then remove the element, it's as simple as remove the first element. I'm sure you can probably guess how we would remove the first element from this vector. We would simply call our vector, and then we would need what is called an erase function. All right, so you probably wouldn't have guessed it off the top of your head. So that's why we're going through it now. And then inside the erase function, we can use the begin. Okay, so we're going to erase whatever is at the beginning of our array. All right, and then we like to print the first element of this array. Okay, so let us just copy this print statement, put it here. So this is the vector elements after erase. So vector elements after insert. So let us run it. Okay, and you can see here it did in fact erase the 5 after we inserted it. So that in a nutshell is pretty much what I'll cover on vectors. So just to recap, vector is just a different type of data structure that you can use to store values in your C++ programs. And as you can see, it's way more dynamic than arrays. And there are a lot more built-in functions that you can use to manipulate your data once it is stored in your vector. A pointer is a variable that holds a memory address. Now for a C++ program, the memory of a computer is like a succession of memory cells, each 1 byte in size, and each with a unique address. So these single byte memory cells are ordered in a way that allows data representations larger than 1 byte to occupy memory cells that have consecutive addresses. Now, pointers and references can be used to access array elements. They can pass arguments to a function when the function needs to modify the original argument. They can also pass arrays and strings to functions. they can obtain memory addresses from the system, and they are used mainly for creating data structures such as linked lists. Now here I have a diagram. We have three different sections. We have our variable, our storage address, and the actual content of this storage address. So in essence, when you create a variable, it is stored at a particular address in memory, and this at this address will have the value. Okay, so variable name, storage address, then the actual value being stored. So when you create a pointer, what it does, it actually saves the value of the storage address to your variable. So let's take a look at this whole concept in the upcoming video. Okay, so to understand the concept of pointers, let us first define a variable x and set the value equal to 5. Now let us print both the value of the variable and the address of this variable. So first, let us print x, and let's do an end, and then let us print the address variable of x. So in order to get this address variable, we have to use the ampersand sign, and this will help us to print the memory address of x. So now when we run our program, we should get both the value of x and the memory address of x. Okay, so there you have it. Now, as we said before in our slide, what a pointer does is it simply stores the memory address of the variable. So if we wanted to store the memory address of x, we could create a pointer, and to create a pointer, we use the star or multiplication sign, and let's call our pointer p. Okay, so we can see that Visual Studio is formatting it correctly for me. So it would be int, then your multiplication, then p. Alright, so if we wanted to actually store the value of our memory address, we could store it inside p. So we could say p is equal to the memory address of x. And then we could substitute this for p, which is our pointer, because we've already referenced the memory address here and stored it in our pointer. So when we run our program, right, so we see that we have now stored our memory address in our pointer. Now just to reiterate, our ampersand is referred to as the address of operator, and our star is known as the dereference operator. So dereference. So what we could also do is dereference our address of operator here. So if we wanted to, we could also print the value of x like this. We could dereference our variable x, and we should end up with the value of x. So let's run this, and there we have 5 again. So those are two of the main things to keep in mind. You have your dereference operator, which is your star, and then you have your address of operator, which is your ampersand sign. So that's really all there is to pointers. you are going to dereference values, and you're going to use your address of operator to actually get the memory address. So you may be asking yourself, what good are pointers? Because it may seem a little bit silly or academic at this point. Why do we use a pointer if we can just use the original value? So a couple of different use cases for pointers. So arrays are usually implemented using pointers, and these very same pointers can be used to iterate through an array. All right. So also they are the only way you can dynamically allocate memory in C++. So this is the most common use case for pointers, is to dynamically allocate memory. Right? So they can also be used to pass a large amount of data to a function, and it does this in a way that doesn't involve copying the data, which is very inefficient. So they can also be used to pass a function as a parameter to another function, which we will cover later on. And they can be used to achieve polymorphism when dealing with inheritance. And we will definitely be dealing with inheritance in the upcoming videos, as we are about to start looking at structures and classes. So, all right, that's it for pointers. A structure, otherwise known as a struct, is a collection of simple variables which are used to represent a record. The variables in a structure can be of different types, like integer, float, string, and so on. The data items in a structure are called the members of the structure, and a structure is defined using the struct statement. Now let's take a look at some code examples. Okay, so now keep in mind that structures are used to represent a record. So suppose you wanted to keep track of your books in a library, or you were building a software for a library and they wanted to keep track of their books. So you might want to track the following attributes about each book, such as the title, and then maybe the author, the subject of the book, and let's say we want to track the book by ID. So usually each record is trackable by a unique ID. So let's say that this is the definition that we want to use for our structure. So let us define our structure, and we will do it right above int main. So let's define our structure. And remember, the keyword to define a struct is this. A structure is the struct keyword, and the name of my structure is going to be books. And then I open up my curly braces, and you can see that it completes my struct here with a semicolon. All right, so I'm going to use several different variable types. So first I'm going to define a char for the title, and we can specify that the title should be no longer than 50 characters. And we can also let's do a char also for the author. And let me just use common letters. So let's also specify 50 characters for the author. We can specify a string for the subject. And for the book ID, let's do an integer. So book ID. Okay, so now we have declared our structure. This is the basic blueprint and the different data members of our structure. So before the semicolon here after the curly brace, I could specify an object, or pretty much just one or more structure variables, but this is optional. So if I wanted to define a structure object from my books. I could say book 1, book 2, etc. And then I'd be able to come down here in my int main and I would say book 1 dot. Okay, so to access structure members after you've created your object, and we will definitely be getting into objects and classes here very soon. To access any member of the structure, we use what is called the member access operator, which is our dot. So you may see that we have been using this so far. An example would be in our vectors video. We looked at how to access certain members or behaviors of the vector using the dot or the member access operator. So it is really just a period or full stop that you put between the variable name and the member that you wish to access. So in this case, you put it between the structure name or the structure variable name and the structure member that we wish to access. All right. Now, this is one way, like I said, of defining an object from your structure. So if you like doing it that way, that's totally up to you. Another way that you can do it is to declare your object. So I would say struct and the name of my structure, and then I would say book 1 and then struct and book 2. So here we are basically declaring two book objects. Okay, so from here we can start adding some data to our objects. So for book 1, if I wanted to add an author, I could say book1.author is equal to, and let's think of an author here. All right, so for this author, let us use Mark, and remember this has to be in double quotations. So Mark Twain is our author. And then we do book 1 dot title. And this is going to be The Adventures of Tom Sawyer. And of course the subject, let's set the subject equal to adventure. And then let us set the ID. And since this is an integer, we only need a number. So let's set it to 001. So you'll notice that we have two red lines here under book1.author and book1.title. And the reason for that is because we have these members defined as char. All right, so we have the title and author defined as char, and we are not able, or it will not allow us to simply set book.author equal to Mark Twain. We cannot assign the string value to a character member like we are trying to do here. So you see that it works for subject because subject is defined as a string, so we can definitely do it like that. In order to be able to set the value to book1.author, we have to use a built-in function in C++, and this function is called a string copy. Okay, so we need to use the string copy. So we see here that it has a property of the char destination and then the source. Okay, and I think nowadays we should be using the string s instead. So yes, let us use the string copy underscore s. So we have the char destination and then the source that has to be passed in as arguments to this function. So in our case, let's open up our parentheses. So the first argument will be the destination, which of course is book1.author. And then the second will be the source, which is what the text we're trying to save. So let's do that. And let's also do it for title. So string s. So let's put our comma, remove the equal sign. Right, so now everything should be okay with this. So let us quickly add some values to our second book. So let's use our string copy. So we're now saying book 2 dot author. Let's set this to Lewis Carroll. That title, and let's set this one to Alice in Wonderland. Oh, and don't forget to wrap it in your double quotes. And then we can just say book 2 dot subject. Okay, well, there may not be much difference between fantasy and adventure, but let's set this one to fantasy. And then book 2 dot book ID. Let's set that to 002. All right, so fairly straightforward so far. So we have set values to both our book objects, book 1 and book 2. Both have values. Now let us just simply print those values out to the screen. So let me do my cout. And I'm going to do some copy and pasting here just to make it a bit quicker. One title. You can say book 1 title. All right, so I'm going to copy this line. So we want the author. Change this from title to author. Then of course we want the subject. And then we want the ID. Okay. So this, let me put a comment here. So we want to print book 1 info. And I'm going to copy all of this. And we're going to print the info for book 2. All right, so then we just change this to book 2. Okay, so now we should be able to print. So let us run our program and see our result. Okay, great. So we get our data here. So book 1 title, The Adventures of Tom Sawyer, Mark Twain, adventure, the ID is 1. Then we have our book 2, Alice in Wonderland, Lewis Carroll. It's a fantasy and the ID is 2. So there you have it. We've successfully created our structure and added some data. So just like with arrays, we can pass a structure to a function. So we can actually clean our code up by removing this duplicate print book info section. So you see here, if we had, let's say our library had, several hundred books in the library, we definitely would not want to have to do a cout for every single book just to print the info. So this is a prime example of why functions make our life easier, because we can reuse them. So instead of printing out book 1 and book 2 info like this, let us create a function that we can pass our structure to and to let it actually print our book title and book information. So first things first, so remember, we're going to define our function after our int main. So let us define our function, and this function will be returning void. So it's just going to print information. So it's not going to return an actual value. So let's say print, let's just call it print book. And we're going to pass in a struct. And in this case, our struct is, the name of it is books. So that's the structure that we're going to pass in. And we're going to just create that object called book. All right. So there's an error here. Oh, this should be books. Right. So we're passing in the structure books and we're actually creating that book object here. So now inside the print book function, I am going to say cout and then now, since we're passing in, since our variable that we're passing in here is called book, we would say book dot title and put our end line. So let me copy this, undo. So we need our author. And then we need our ID. All right, so that should pretty much be it. So now that we have our function defined, we have to put our prototype. Okay, so now that our prototype is matching our function, we can remove this section and clean it up. So here we just want to print book info. So now I can simply call my function print book and pass in book 1 and pass in book 2. All right, so now if we run this, there we have it. You see that it prints both the information for both of our books. So our function just made our life way easier. So it abstracted away all of the code, and this could have been something very complex, like a complex algorithm. So if you wanted to abstract away all of the work or the code behind being able to print a book, that's exactly what you have done. You have defined a function that prints a book, and then it prints the different information about the book. And of course, we defined the prototype, and then we just have to pass in our book in a function call, and it prints our book information for us. Now, you can define pointers to structures in a very similar way as you can define a pointer to any other variable. So you can actually store the address of a structure variable in a defined pointer variable. All right, so remember we looked at our reference and address of and our dereference operator. So let me modify my program just a little bit to show you how we can actually use pointers to point to our structure. So first, let me modify my function. So let's say I wanted to create a function to accept a pointer to my structure as the parameter instead of just the actual structure. So we could actually put our dereference operator here, and now you see we're getting an error here because we have to change the way we access the title. So now that all of these are pointers, we now have to use this arrow notation. Okay, so it's just simply a hyphen and a greater than sign. And we have to do that for all the different members, because now we're dealing with a pointer. So we're actually just passing that reference. So we also have to modify our function. So we're also going to put our dereference operator. And now we're actually going to put our address of operator, right? So it's not recognizing the structure, so we just have to put that here. Okay, so now we have our function modified to where it's actually pointing to the structure, and here it is referencing it and pulling those values from that address location. So now if we run our program, we should still get the same information. So this is, remember, structures and pointers rather is a more efficient way to access our values. It is really more faster. The compile time is shorter. And this is really a concept that just think about hundreds of books or thousands of books and having to print information for all of these. So this would make it a way more efficient process by using your pointers and reference symbol here. So all right, so that's it for this video, and we are going to definitely dive into classes and objects.